Hey everybody. All right, so sorry I'm not there, but we are going to talk about adding vectors in 2 dimensions and being able to fully classify those resultant vectors. Um, what I mean by that is when we fully classify, we need not just the value of the hypotenuse, so it can't just be, this plus this equals same length, tip to tail. This would be our result. So we can't just find the value of this resultant, but we also need to know this angle. Remember that angle is theta. So how do we do that? Well, it's back to trig, and you should be taking notes starting from now. So what this is called is finding the resultant angle. And it comes from that same idea that we had talked about of SOHCAHTOA. When we're finding the resultant angle, the piece we care about is right here, is the TOA part. So just to remind you, on a regular standard triangle, standard right triangle, where this is our angle, this side, the one that's farthest away, is our opposite side. This one's our hypotenuse, and this one is our adjacent. So tangent of theta is the ratio of how long the opposite side is to how long the adjacent side is, depending on what angle this is. Obviously, the larger this angle, the longer opposite side is going to be. So if you have a really high angle, that might be an angle of 80 degrees. If you have a really high angle, your opposite side is going to be really long, and your adjacent side is going to be really short. So just sort of a different way to look at it. So when we use tangent of theta, we don't really use tangent of theta. What I mean by that is, going back to tan theta equals, I'm just going to call it O over A, just to abbreviate a little bit. We want to solve for this angle. So you can kind of treat tangent and theta, I just want to show you what this means. You can kind of treat tangent and theta as two separate functions, almost like we're doing x times y equals opposite over adjacent. So if we wanted to get rid of tangent on that side and leaving just y, so really like you can think of it as tangent is x and y is theta, we want to get rid of x. The way to do that would be to divide by tangent on both sides. But that's kind of weird. So instead, what it really looks like is, and by the way, students, if there's an issue, I'm going too fast, just have the sub pause it, no problem. So tangent of theta equals opposite over adjacent. If I wanted to do x times y and get it over on the other side, let's say x times y equals 4. Whatever, doesn't matter. Another way, rather than dividing by x, I can multiply by the inverse of x to the negative 1 on both sides. So x to the negative 1 times, this is really x to the 1. When you have exponents, those add, so that's x to the 0, which x to the 0, anything to the 0 is 1. So you're left with y equals 4x to the negative 1, which would be the same as y equals 4 divided by x. So it works the same way, and what we're going to do is multiply by what's called the inverse tangent on both sides. So the inverse tangent, tan theta, equals inverse tangent, what you do on one side you have to do on the other, of opposite over adjacent. So what this means, just like we did x to the negative 1 times x, this piece right here effectively cancels out. So it leaves just theta on that side. And we're left with tan to the -1 of opposite over adjacent. So when we're solving for our angle of a triangle, where we know the opposite side and we know the adjacent side, and we can solve for the hypotenuse using Pythagorean theorem, we're going to use this equation to find out what this angle is. And that's absolutely crucial. First of all, obviously, just like we needed to be before, we need to be in degree mode in our calculator. Various calculators are different, but I think you've all figured out where the degree mode option is on your calculator. So, theta equals, this is called the inverse tangent of the opposite side over the adjacent side. In order to properly define what that vector is, and you'll see an example shortly, you need to have this angle. So this one would be, there would be our directions. So this one would be whatever theta degrees north of east. So this button on your calculator, if you look at your calculator, this is mine, for example. If you look at your calculator, one of the buttons should be tan. Right above it is usually inverse tan. So on this one, I press Shift tan, and my Shift button is yellow. So right above the tan, it says tan to the -1. That's the same button you're going to press. And let's do an example together. So you should have your calculator out. Let's do an example to see if we can get the correct final resultant vector. So let us add, remember that theta is inverse tan of opposite over adjacent. So let's add vector A, which is a length of 40 meters, plus vector B, which is a length of 20 meters. So we draw tip to tail. Just draw it over here. We want it relatively to scale, so if that's my 40, 20 is half of 40, so I want something about there. And my resultant is going to be from where I start, pointing down to where I finish, so that's my resultant. And I need to classify it. My result is always, my angle, always comes from my, basically think of this as the clean side of the triangle. So my angle is a result of the clean side of the triangle, meaning I have no arrowheads pointing from this side. 2 arrowheads, 1 arrowhead, no arrowheads pointing from this side. It's also from the side where I started, connecting to my hypotenuse. So that's my angle. And I want to use my theta equals inverse tangent. The reason we use opposite and adjacent, I could find this side using Pythagorean theorem, but remember, I like to say, don't use something you have to calculate, because what if you got that calculation wrong? You're given the 40 and the 20. So if you use those, you know you're not going to get a wrong number if you use the equation properly. So that's why we use inverse tangent. Once you find r, you could use inverse sine, inverse cosine. It doesn't really matter. But we know the opposite side. We know the adjacent side. So we should use those to make sure that we absolutely are not wrong. So first of all, we want to properly identify what our resultant is. To do that, we need to find the size. Well, the size is Pythagorean theorem. So r squared equals a squared plus b squared, 20 squared plus 40 squared. 20 squared is 400. 40 squared is 1600. So r squared is 2000. R is the square root of 2000, and the square root of 2000 is, just going to find my square root button. There it is. 44.72 into, that was meters. Should put those units. So my R has a length of 44.72 meters, something we've done before, finding that length. So what I'm classifying, R is 44.72 meters at, got to have that at symbol. We need to find the degree, And then we have to measure. Remember, when our angle is touching, it's going to be touching one of our sides. So in that case, our side is, that's our blank degrees. Ignore that piece. Add blank of blank. The side that we're touching is our south direction. The one we're touching is our second one. And then we look at what direction this is. This green vector itself is in the southwest quadrant. We've already used south, so the thing we're left with is west. So this angle is west of south. And we have to find this angle, but that's where our equation comes from. So the angle is going to be inverse tangent of, our opposite side is the 20, divided by the adjacent side is 40. So I can simplify that. You don't have to. You can put that right into your calculator just like this, as the inverse tangent of 0.5. So on my calculator, I have to do 0.5, then inverse tangent. Some of you will type it into your calculator just like that. Depends on the calculator. And when I do that, I got an angle, making sure you're in degree mode, of 26.565. So we'll call that 26.57 degrees west of south. So when I add a vector of 40 meters south and a vector of 20 meters west, my resultant vector, this green one right here, has a length of 44.72 meters, but is fully classified with the angle, 44.72 meters at 26.57 degrees west of south. Let's do one more, and then you're going to work on the worksheet for the rest of the period. All right, so let's add this of length 300 newtons plus, let's go up of, that looks like it's about 200 newtons. And we're going to solve. So, again, we want to first start by drawing our vector tip to tail. So we've got 300 right where the first one ends, the second one begins. That's about 200. So yeah, 200 newtons, 300 newtons. Our resultant goes from where we start to where we end. That's value R. And our angle is our clean side, which is right here. So our angle is that angle. Theta is inverse tangent of opposite, which is 200, over adjacent, which is 300. Once you identify your angle, it should be relatively clear to say that that's our opposite side of the triangle, this is our adjacent side, and this is our hypotenuse. So I can do that right away. 200 divided by 300 inverse tan. I get 33.69 degrees. And again, the way I just verbalized it is how my calculator requires me to put it in. I have to figure out the decimal first, so 2 over 3 is 0.66. I have to find that decimal and then do the inverse tangent. Some of you will just press the inverse tangent. Your calculator will show you when you type it in, it'll be inverse tangent. And then you type in 200 divided by button 300, and it would hit enter, and you should get that same number. The final thing, find the result. And I'm going to skip showing the work for the Pythagorean theorem, but I will verbalize it. 200 squared plus 300 squared gets, oh, that doesn't make sense. 200 plus, oh, that did. Square root of 130,000 is 360.56. So 360.56 newtons. So my final result, fully classified, is 360.56 newtons at, here's my angle, 33.69 degrees. And then this is east, so that's of part of east. My other option, my green, is north. So my final result, 360.56 newtons at 33.69 degrees north of east. So on the worksheet, I want you to draw this, find the angle, and fully classify each of the resultants. And I will check that on Monday. Thank you.